All right, we're going to finish lesson 1.3, 1.4, analyzing functions. And in example 4, we're looking at finding the domain of functions. And remember, the domain is the set of input values that work for that function. So you would not include any x values that are undefined or that give you an undefined answer. We've got these different functions here. A is just a function of 5 points. So there's 5 inputs and 5 outputs. And so the domain is just, you're going to list your input values or your x's. So your domain would be x's, the x values of -3, -1, 0, 2, and 4. So you're just listing the first number in the ordered pair. The range would be all those different y values. So that's one kind of function. Let's look at B, where we've got that is a rational function because we've got a fraction going on. And you have to ask yourself, where would this function be undefined? And you're only going to have an undefined answer if you are in the fraction dividing by 0. So then you ask yourself, well, what would make the bottom 0? So you're going to set the bottom equal to 0, subtract 5 to the other side, and you see that x equals -5 would give you an undefined answer because it's going to give you 0. So that's called a restriction. That's a restriction on the domain. And if the domain's restricted at only the number -5, then it should work for every other number. So that means it works from -infinity to -5, and then it'll work again from -5 to +infinity, but it doesn't work at -5. So that's why we're going to split it at -5 and put parentheses there. If I put brackets on a -5, that means it does work. Parentheses means it does not. So parentheses means that -5 is not included in the domain. We also put parentheses on the infinities because you can't theoretically ever reach infinity. So we're just going up to infinity. All right, so C, we're looking at the volume of a sphere. The volume of a sphere. Now the input here is R. The input is R. Now, if this wasn't a real-world context, we could plug any radius in, any number we want for R, because there's no fraction to worry about, so we're not dividing by 0, and there's no square root, which we're going to look at in the next example. In square roots, you can't have negatives inside. So there's nothing to worry about. Now, in part C, we are talking about a real-world context. We're talking about a real sphere, an object, and the radius of that. So in the real world, you can't go into the negatives for radius. The radius, and you can't have a radius of 0 because then you don't have a sphere. So we're looking at, if we actually have a sphere in front of us, it would have to be a radius greater than 0. And the radius could be as big as you want. So you can have from 0 to infinity. So the radius could go from 0 to infinity. Now we can't reach infinity, so we're going to put parentheses on it. And we don't want to have a radius of 0 because then there is no sphere to talk about. So we're just going to have parentheses there. Okay, D, we're looking at finding the domain of this function, which has a square root in it. Like I said earlier, square roots, whatever's inside, have to be positive, or they could be 0. So 0, whatever's inside the square root has to be greater than or equal to 0. So we're going to take the inside, whatever's inside, and we're going to make that greater than or equal to 0. It has to be positive, but it could be 0. All right, so from there we're going to solve for x. We're going to subtract 4 to the other side. So it'll be -x squared is greater than or equal to -4. We're then going to divide by -1. So when you divide by -1, you're going to have x squared. You're going to flip your inequality around because you're dividing by a negative. Then we're going to take the square root of both sides. And you're going to get plus or minus 2 when you take the square root of 4. So that means this function only works when the x values are less than or equal to -2 and less than or equal to +2. Now, there's actually a little bit of a problem there. And if you were to plug in something less than -2, like let's just say -3. If you plug in -3 right now into the highlighted part, you're going to have 4 minus 9, which is negative. So the reason for that is when you put the plus or minus, when we took the square root of 4, that works for the +2. So we're going to go ahead and change that to just +2. But for the -2 part, you have to flip the inequality. Just like when we divided by a negative, when we add the negative on the 2, we have to flip the sign around. So now this should work, and you can test some numbers that are greater than -2, like -1, and then if you plug that into the highlighted part, you'll see that it is greater than or equal to 0. Okay, so this is our domain then, but we're going to write this in interval notation. So let's start with the -1. The x's have to be greater than or equal to -2. So if it's equal to -2, we can put brackets on it. Greater than would mean we can go to infinity. However, when we look at this one, this says you can't go to infinity. That part says you have to stay less than 2. So instead of -2 to infinity, we can only go from -2 to 2. And then there are that you can equal to, so you put brackets on that one. So -2 to 2 with brackets is your domain. And that means you can plug in -2, you can plug in 2 into this highlighted part, and you'll get an answer that you can take a square root of. And you can plug in any number between them, and you can get a positive answer and take a square root of it. Let's look at E. We've got a fraction again. So try pausing the video for a second and see if you can start this problem and find the domain of it. And if you've tried that, let's look at it. You want to set the bottom equal to 0, because whatever gives you a negative inside is going to create an undefined answer and restrict your domain. So we're going to subtract 5 over to the 0. We're going to take the square root of both sides. And then we're going to see that you have a square root of a negative. So if that gives you no solution, then there's no restriction. If there's no number that's going to give you 0 down there, then there's no restriction. And if there's no restriction, then you have all real numbers as your domain. So -infinity to infinity would be your domain for E. For F, if you want to go ahead and try that one and pause the video. This is a lot like part D. So the inside, whatever is inside your square root, has to be greater than or equal to 0 in order for it to work. So, and then that is already solved for. So you just have x is greater than or equal to 0. That would be your domain. So that means we are starting at 0 as the lowest number it can be. And we can equal it because there is an equal to sign on it. And then comma x is greater than 0. And there's no restriction. There's no stopping point like there was with the 2. So you're just going to go to infinity. So 0 to infinity would be the domain of F. Now moving on to example 5, we're going to analyze this graph. The first A, B, C, D, E are evaluating the function at certain x values. So f of -3 is what A says. F of -3 wants to know the function value at the x value -3. So if we go to -3 on the graph, right here, we're going to see that it's an open circle, which means it is undefined. It hasn't been filled in, so it hasn't been defined. We don't know what the y value is. Okay, B, f of -2. So we find -2 on the x, we go to the graph, and they're asking for what is the y value on the graph, and that would be -4. That point down there is at -4. So when you go to -2, the y value, or the function value, is -4. Okay, f of -1. So we're looking here at this point where x is -1, the y value is -2. f of 0. When you look at 0, there's a y value of 0 there. F of 1. You go over to 1, and there is a filled-in point at -4. So the y value there is -4. Domain of f. So that is how far left does it go. It goes all the way to -3, but it doesn't touch it. So we're looking at the x-axis. It goes all the way to -3, but doesn't touch it. So we're going to put parentheses on a -3. And then all these x's have y values until you get to 1, and then it stops. And so it's going to stop at 1, and we put a bracket on it because there's a filled-in point. So there is a point at 1. The range would be the y values that are being used in the function. So we see the lowest y value that it reaches is -4. And there's a filled-in point there, so we put brackets on it. And the highest y value being used looks like 0. And even though it's empty at -3, it's still filled in at 0, 0. So 0 does work, and there's going to be a bracket on it. All right, increasing intervals. Where does the graph increase? Which means where does it rise from left to right? And that would be starting at -2 and then stopping at 0. This is the section of the graph that is going up from left to right. So we're going to write that as an interval with parentheses. So that would be it starts at -2 and it stops increasing at 0. Intervals of decrease. So it looks like it's decreasing twice. It is falling from left to right from -3 to -2, and then it's falling from left to right from 0 to 1. And I'm talking about the x values. We always use the x values to describe an interval. So we're going to write that as -3 to -2 and from 0 to 1. Those are x values. All right, intercepts. So that would be x-intercepts and y-intercepts. -3 would be an intercept, but it's not filled in, so it's not actually crossing. 0, 0 is your x and your y-intercept, and that seems to be the only one that is touching x and y, the x and y axis, and filled in. So 0, 0. Relative maximums and minimums. So for a relative maximum and minimum, you have to increase and then decrease. It has to increase and then decrease. And whatever point you have where it's changing from increasing to decreasing is your maximum. For relative minimums, you have to decrease and then increase. So the absolute maximum is the highest point in the whole graph. The absolute minimum is the lowest point in the whole graph, but that's not what this is asking. This is asking where does it change from increasing to decreasing, which is a max, and decreasing to increasing, which is a min. We're going to see the only maximum is here, where it went from increasing to decreasing. So 0, 0 is your only relative maximum, and your only relative minimum is here at -2, -4. Because that is the only place where it changed from decreasing to increasing. Example 6, we're determining whether the functions are even, odd, or neither. Even has y-axis symmetry. And odd has origin symmetry. And neither will have neither of those. All right, so y-axis. So we're gonna test these. For y-axis symmetry, you plug in negatives for your x's. So, and let's just change f of x to a y